who am I? I've been working on both WebKit and GStreamer for quite a long time now, since 2009. I'm reviewer in WebKit and trying to review some code in GStreamer as well from time to time, and committer in both. I'm partner at Igalia. So actually, a few words about Igalia, just to say that we are a cooperative, worker-owned company. We are around 80 people nowadays, working all over the world, and we provide consulting services around free software services, free software projects. So what WP stands for, Web Platform for Embedded. There's a missing slide there. But so to give the outline of the talk, I will give an overview of the port, what you can do with it, how it works, and have a hands-on part about integration in IMX board, IMX6 and IMX8M boards. So WP basics, it's a WebKit port, so it provides API and platform-specific implementations of the cross-platform interfaces of WebKit. We base our release cycle on WebKit GTK because actually we maintain also WebKit GTK, so it's quite convenient for us to maintain a single branch with all the security updates and the backports from trunk. WP is quite interesting in a sense that it doesn't integrate with any UI widget library by default, and that's deferred to a plugin system we called View Backends. So we have View Backends for a wide range of platforms, Wayland. We have an ongoing experiment with on Android platform as well, though it's not upstream yet. And then for specific platforms, we have some backends. I can't really tell much about that, but we integrated WP on a wide range of exotic platforms you wouldn't think of in the first place. It's a bit scary, actually. But the main backend we have is called FDO. Stands for freedesktop.org. That's what we recommend in WebKit, in WPEWebKit upstream, because that's where most of the upstream developers work on nowadays. It relies on the FDO stack, so that means Mesa, and it provides some API for specific things, for access to EGL images, which is quite convenient in some cases. So you get access actually to the EGL images representing the web view contents from your application. That's quite useful. And of course, it works on Yocto and Buildroot, so it can be enabled in your platform quite easily. We have meta layers for that. I will talk about it later. So this is about multimedia, so I should talk a bit about the multimedia backend. I guess maybe you already know what's GStreamer, so I don't really need to go into the details of that. But it's just to give a brief introduction. It's a cross-platform multimedia framework, allowing to build multimedia applications. And here you can see an example pipeline of OGG Vorbis media player. It's quite simple, actually. You have the source, the data source at the left, and at the right you have the rendering in audio and video syncs. And in between you have the decoders, demuxers, and so on. So the data flow goes from the source to the syncs. And then you can really build really complicated applications with GStreamer, like with thousands and thousands of elements, and it's quite powerful. So we use GStreamer in WebKit to implement the support for audio and video, as you might have guessed. We rely a lot on a GStreamer plugin called Plugin, which does all the heavy lifting of building the pipeline for us, and it provides some high-level properties and signals that the application, which is WebKit in our case, can use. We have GL rendering, so in WebKit, all the layers of the web page are composed together and blended together, and the video is one of those. So we need to have our player to provide a texture to that infrastructure so that the video frames can be composited in the final page. In WebKit, there's a library called FastMalloc, which is it provides the equivalent of the Malloc infrastructure, but it's specific to WebKit, so we had to integrate that in a custom allocator. And then for supporting codecs, we had to build a whitelist of codecs that we know work well. That's actually useful for the MediaCapabilities backend, which I'll talk about just in a few minutes. Another spec that's quite important nowadays in the web is called adaptive streaming. It's the equivalent of HLS, Dash, and so on, but built for the web. So I just give a brief overview of what my colleagues did there, Alicia and Enrique. So in MSC, the web application will provide chunks of video to the application, and those are called source buffers, and they give really fine-grained control of the data flow to the application, so that you can, for instance, insert ads in the middle of your video quite easily. Video resolution changes handled better and more naturally. And those chunks are demuxed in a specific pipeline we have in the backend, and then injected into WebCore, and then played back afterwards. So we have a custom player for that, and a custom source element which takes those samples coming from WebCore and played them directly. So they are already demuxed and ready for playback. We had to make quite a few changes in GStreamer upstream to get that working quite well, especially for WebM and the MPEG-4 file format. So yeah, it was a long road, but we managed to get quite a few patches integrated in GStreamer. Now they are all upstream. I won't go into the details of that, I don't really have time. So the backend is now considered quite mature. We use it in a wide range of platforms and even on desktop as well on the GNOME web browser, which is quite cool. We also provide upstream integration with EME, so that's only the basic infrastructure. Right now we only support ClearKey, but if your project needs to support another encryption scheme, such as white vinyl clarity, you have to do it yourself currently. We support VP9, Opus, and all the mainstream codecs that are available, for instance, on YouTube. We actually rewrote the source element we have for MSC recently, and it now relies on the new generation playbin element, which is called playbin 3. Don't ask me why it's playbin 3. I could go. It's a funny story, but so now that's actually landed in upstream since recently. There was some regressions, but we are still dealing with those. And another thing we plan to work on is multitrack source buffers. So that's not really widespread used in the web, but it's nice to have at least for test coverage. And in that case, basically the web application can provide multiple tracks at the same time, and WebKit can just select the ones it wants. Another spec we've been working on, it's still a draft spec, and it's about letting the web application probe for the capabilities of the browser. both on the encoding and decoding level, so that the application can just feed the right content to the browser, and we are sure that it will work. So yeah, it's quite simple. It's still a draft, but actually it's used on YouTube TV, so that's mostly why we decided to implement it. And the backend we have for GStreamer of that spec is quite simple, actually. We had to provide a way for the application to know which plugins are actually backed by the hardware. So we added a new metadata for that in GStreamer. And then we think that it would be nice for specific plugins to do some probing when they are rolling up, when they are pre-rolling their internal state. So that's not done yet. Although we also added support for I can show it maybe in later on, but every plugin can advertise which capabilities it supports, which is called caps in GStreamer. And we, for specific plugins such as the video for Linux, we refine those caps based on what's supported in the kernel. So I did that for the AVC1, and it could be done actually also for the VP9 and VP8 at least. And then for more decoders such as VAPI, or it should be done as well, if possible. So we have that working only for the decoding, and for the encoding, which would be useful for WebRTC, I think, it still needs to be done. So there's still more work to do on that backend. So WP is actually a library, and you can use it in your applications. I'll just give a few examples there. The flagship browser we use is called COG. It's really simple. Actually, there's not even window decoration at this point. It works on desktop, but it's mainly aimed for embedded use. And it provides a simple API like for navigation, reloading the page, and there's some debug support as well. And the default backend we use for that browser is the FDO backend, which we consider mature, and there's a new backend we've been working on lately, which directly relies on libdrm and GBM and libinput. And it works quite well already. And we have good hopes about that. Another thing I've been working on as part of our collaboration with Safran is the Qt5 QML plugin. So it's actually quite cool if you have an existing Qt5 application that's using the QtWaveview API, QML plugin, and you can directly swap it with the WP plugin. And the API is compatible. So if you don't want to use the upstream Qt5 WebView plugin, which is actually old and not maintained anymore, and probably has some security issues, you can switch that to that new plugin. But the inconvenience is that it works only on Linux and with Wayland. If you want to check, the announcement is there. And then the third application I thought about talking today is GStWP. We've been using GStreamer in WebKit for quite a long time now, and actually we never really thought about doing the inverse until recently. So now you can actually use WP in your GStreamer application. So if you have, you can directly embed WebKit inside a GStreamer pipeline, which can be useful for HTML overlays, for instance, in live TV broadcast, or maybe I can show a demo later if I have time. And it's actually, people have been doing similar things with Chromium for for some time already, but it's not really optimal because it's the frames coming from the browser are actually in system memory, not in GL. So you can't really you have to do a memcopy to upload that to the GPU, and it's not really good. And in WP, it's directly available in the GPU, so you can do the composition directly there in the GPU. And actually, and also one last thing is that Chromium is not really nice to use in application. There's the Ceph library, but you have to do some hacks. I saw some really nasty hacks to use that in GStreamer. With WP, the integration was really smooth and quite nice. So now, last part of the talk is about integrating WP in your boards, in your IMX6 and IMX8 boards. I won't talk about build route. I will focus on Yocto, but I know that people are using build route quite already. So at Igalia, we provide a layer called MediaWebKit, and it packages the main backends and applications that you can use with WP in recipes for that layer. Also, it's good to have the GStreamer layer, even though the updated recipes are progressively moved to POCI directly to the standard reference distro of Yocto. So it might not be needed, it can be optional. And the MetaFreescale layer is also useful. I don't really remember why, but and what we've been using is the Naviv kind of driver. You could actually also use the Vivante driver, but I don't see any reason for that at this point, because Naviv provides all the features we need, and the efforts made by the community to reverse engineer the Vivante driver are really useful. So you need a recent kernel. I say for 19. Mesa, of course, because that's where the Naviv driver is hosted. Wayland and GStreamer for playback. And then I know for sure that the FDO backend is working quite well in that environment, because I work daily on that. The RDK backend should also work, though it's less tested in that environment. And then if you want to have playback working, you need the Video for Linux plugin, which are part of GST plugins good. On IMX6 for decoding, we rely on the Coda 960 driver. It's working quite well. Actually, we have Full HD working at 30 FPS in H.264. But in some cases, it doesn't. It stutters a bit, so the rendering is a bit. It's not really smooth. So in the MediaCapabilities backend, we added support for that environment variable that you can use. It's quite useful, especially in YouTube, because YouTube can provide both Full HD and 720p. But if we use that environment variable, YouTube will provide only 720p, and the playback will be smooth. And on IMX8M, things are still moving quite a bit. The Intro G1 kernel driver is scheduled to be part of the kernel 5.4. I saw this week a pull request in GStreamer sent by Pengutronics, and they are adding support for V4L2 for that hardware. So it's going to be reviewed soon. And there, the status is that we have Full HD working, and we will support more codecs such as VP9 and HEVC. But that's still ongoing, so for the long term. Right now we focus on H.264. And I wanted to conclude with last thing about YUV. In WebKit up until recently, we relied on RGBA video frames. Though in some cases we noticed that it had significant performance impact, especially like for the Vivante driver and Naviv to some degree. So we decided to add YUV, interleaved YUV support in WebKit so that we can reduce a bit the number of color space conversion. And in IMX8M, the cost of doing that conversion is a bit similar, I think, to what's done for RGBA. So so it's still a gain for us. There are a few regressions related with that in WebKit. We are polishing a bit a few things, but it's already working well. That's all I have. If you have any question or want to discuss anything. Yeah, I think you have a microphone.
Slide. In one of your slides, you mentioned Android support for WPE.
Yeah.
But from what I know, there is no GStreamer in Android. There is only OpenMax. No?
No,
so how you link both?
Well, you can use GStreamer in Android.
Okay.
Yeah. But the efforts we've done about that were not related with MediaCapabilities Back-End. It was only about rendering basic web pages.
Okay. And do you target to support OpenMax? No?
Well, yeah, there are GStreamer OpenMax plugins.
Okay.
So depending on your platforms, they will be used or not by, they will be selected or not by the play bin element, by the code bin.
Okay.
Do you have much in play? Do you have like an equivalent of Chrome driver for automatic testing, WPE? Because in Chromium we're doing some EME playback, and we've got some tests where we can drive the browser and to get some automated results.
Mm-hmm.
Just wondering if there's something similar already.
Yes. Yes. There is an ongoing effort to actually provide a specification about that, I think. It's called WebDriver. And we have a backend for that in WPE, and it's working quite well. So you can automate testing in WPE as you do in Chromium.
Okay.
So do you still have time? Okay, so I can't show the other demo yet, but all right, thank you.